Good evening. Today is Thursday, March the 4th. Today in geometry, we looked at angles of elevation and depression, and I will show you a couple of examples so that you can see the type of problems you have to work there. When you're looking at angles of elevation or depression, the first thing you're looking at is your angles are coming off of the horizontal. So if this is your horizontal line here, and you come over here, an angle of elevation would go up. So this angle right here, this angle, let's call it alpha, would be an angle of elevation because it is going up. You're looking up from the horizontal. If you're looking at a angle of depression, depression means to go down, so your angle of depression would be something like this, and that angle would be this angle here, which we'll call it Bravo, because it goes down like this. Now, so when you're looking at angles of elevation or depression, you're working problems that are connected with right triangles trigonometry. So if I erase what I've got here and kind of show you an example of a problem, then you could say if you have, for instance, one of the problems in the textbook, you have a lifeguard sitting here in his chair on the beach. Here's the lifeguard's chair, and he's sitting up here. It's kind of looking out, and he spots a swimmer out here at some distance away. So his angle of elevation is, if we go, see, here's your horizontal. So if you look at his eyes right here, that's the horizontal, which is level with the ground. And then if you come in here and see, okay, now you draw his line of sight from here down to the swimmer, then you can say, okay, he's got, let's say his height from his eyesight to the ground here is 10 feet. And then this angle of elevation looks to be about 15 degrees, or angle of depression is 15 degrees. Now, if you remember, so our triangle here, if I come back in here and get me a different color, so we can draw a triangle here from his eyes down to here, which is, and then we go from there out to here, where the swimmer is, and then we go from there back up to his eyesight. So now we have a right triangle. Now, the interesting thing about that is, if you remember parallel lines, if this angle right up here is 15 degrees, then this angle right in here is also 15 degrees. So, and I'm looking for this distance x here, which is the distance from the lifeguard here to the swimmer out here. Now, so when you have something like this, your basic relationships, the SOHCAHTOA relationship, if I do this, the text, we can come in here and we can do SO, which is SOH. Remember that sign is opposite over hypotenuse, and then CAH is cosine is adjacent over hypotenuse, and tangent is POA. So that's the relationship for the three basic trig functions, which are sine, cosine, and tangent. So if you look at this, I'm going to get rid of this little tick mark right here. I'm going to get rid of the SOHCAHTOA, but undo. Okay. Undo again. Okay. Now, So what we have here, when you look at a problem like this, you ask yourself the question, okay, I have an angle 15, I have the opposite side, and I have the adjacent side. So I can look up here at one of these three identities, and I can say, okay, the opposite side and the adjacent side, that ratio gives me the tangent. So I can come down here now and say the tangent, if we put this in text, the tangent of 15 degrees equals the opposite side, which is 10, divided by x. Now that's my equation that I have to solve. And if you multiply both sides by x and divide both sides by tangent 15, you get an equation that says x equals 10 divided by the tangent of 15 degrees. Now, if you put that in your calculator, make sure that you're in degree mode, and in your calculator, look and you say, okay, you divide 10 by the tangent of 15, and you get an answer of 37.3. So 37.3. So your problem tells you that this distance x here is 37.3 feet. Now that's one of the types of problems that you can use. Now that's angle of depression, okay? So now you can pause for a second and look at this problem, and then I'll show you an example of a problem using the angle of elevation. So if you've got this, I'll go ahead and erase this. So we're going to erase all of this. Now, so your angle of depression, if you look, you can draw, let's say, I'm sorry, the angle of elevation. So we can look here and say, okay, if I have, for instance here, I'm standing here, this is my eyesight, so this would be my eye level, and I'm standing over here, and I want to find out, and I'm looking at, see, so that's my eye level, so ground level would be right about here, so this is ground level, and I'm looking over here at a building, and let's say this building is up like this, see, so I can draw the building here. And I want to find out how tall this building is without having to climb up it or do anything that is out of the ordinary. So if I know, for instance, here that my eyesight, that my eyes are, let's say, 6 feet off the ground, okay? That's a nice, easy number. So we can say, okay, we got a fairly tall person here. Eyes are 6 feet off the ground. Now, and then we can come in here and say, okay, the angle of elevation, which is going to be from his eyesight to the top of the building here. Let's say this angle of elevation is, that looks like about 35 degrees. And I know I can measure and figure out that, let's say I am 100 feet away from the building, from the base of the building. So I'm 100 feet, and that's from here to here. Now, so I know if I look, so if this part over here is 6 feet, then this part right down here is also 6 feet. So then I can look, so I've got a triangle here that is I'll draw the triangle here in a different color once again. We can draw the triangle in red. So we have a triangle that goes from here down to here, and then from here, and we'll do that. All right, and then I go from here. Yep, it won't let me turn loose of that. Okay. All right, so I'm going to go from here. All right, let's do this. Now, I come from here to here. So there's the other side of the triangle. And I can go from here to here. So there's my triangle that I'm interested in now. So if I go back, I'm looking to find how tall the building is. So I've got to figure out this H right here, which goes above the 6 feet that I'm looking at. So then I can come back in once again. Now, most of these angle of elevation depression, you're going to end up using the tangent function, which is the TOA, because here's your angle. What I'm looking for is the side opposite the angle. And what I know is the side adjacent to the angle. So once again, I can come up here and I can get the tangent of 35 equals H divided by 100. Now, in this case, all I have to do to solve my equation is just multiply both sides of the equation by 100. So I have H equals 100 times the tangent of 35. And if I stick that in my calculator, I get 100 times the tangent of 35, and I get an answer of 70 feet. So 70.02, but that rounds to 70 feet. So if I have 70 there, so that means this part right here is 70. So my building has a total height of 76 feet. Now, these are the two basic type of problems that we worked on today. Tomorrow we're going to do a little exercise out on the football field to determine the height of some of the light poles on the football field using these same types of concepts. So if you look at your homework assignment, if you have any questions about how you work those, then send me an email and I'll get back to you. But I'll stop sharing here and we'll end this recording.